Any questions? Yes.
Any way to align a string to the right, or like multiply by a string or something? For 8C final, the right triangle.
8C, this one here?
Yeah.
All right, so so you wonder how to move the stuff to the right?
Yeah.
What you have to do is you have to use system.out.print, not print on, but print, to print a space, and then put that in a loop to print the correct number of spaces. So there's no easy way to, like there is in Python, where you can say the string multiplied so many times. So in fact, that's an attraction for me because I wanted you to practice loops. Yeah, so the way this one is done is simply that you have a loop that prints so many spaces, and then this one here you can just call substring. You just have to call substring with the right value. So it's a loop in a loop. Oh, that's the way it is. Other questions? All right, let's see what we have in Piazza. Let me make this a little bit bigger. So, in fact, let me type this so that it's actually correct. So what the person here has is they have a loop like this, and the question was why not just set the Boolean to true and during the loop set it to false? Oh, I think I know what the question was, what it really is. If not, I'm going to make it to be like this. What I've done is I've produced loops like this. So there's a bunch of times in the book where you're going to be seeing this kind of loops. So here, some work. And so the shape of the loop was like this. We said Boolean done is false, while not done, do some work. And now after that work, it becomes apparent whether we want to keep on going or whether we're really done. And so if that's when we can do this check here. And so I believe what the question is about is, why set it up in this way? Wouldn't it be simpler to set it up in this way, where we have the Boolean variable start out as true, and then we set it to false? The only difference is this one notch here, right? Otherwise, it's the same. And of course, the flipping of the true and false. And so I guess the question is, why am I doing it as while not done? And in fact, I used to do it in a different way. I used to, and I would just call this thing more. And I used to do it like that. And somehow, and I don't know why, somehow a lot of people didn't like it as much as this one here, because it seems to be more satisfying to set done to true than it is to set more to false. It's both completely the same thing. One way you say, is there more work to do? And the other one says, am I done? But somehow it's the question, am I done, seems a more natural one to many people. And so that's why I've switched it, that I've consistently used this form. If you prefer the other, now by all means do that. Just make sure to use a good name for the variable. Check doesn't, I don't know, is not very evocative of what you might want to do. All right, see if someone has trouble with the shift method in homework 8, part C. And he says he gets the right words and then he puts it into NetBrat. Okay, well, let's actually look at this shift method here, because this is a good example of how one goes about and designs a loop. So each time that we do this, that we print a line, let's take one somewhere in the middle, like this one here. We print two substrings, so there is a substring that goes from some index, we don't quite know what it is, to the end. And if you don't specify a second parameter, then it automatically goes to the end. And we follow that without printing a new line by doing the substring from 0 to some other position. And so the question is, what are the indexes here? And so I might call this one K here. And let's just pick an example here. In this case here, K would be what? To print the REA here, I'm not including the third characters. So sorry, I'm the wrong one. To do the SSURING, I'm starting at 3. So in this case, it would be 3. Over here, the substring would go from 0 to also 3. Oh, that's interesting. Are they always going to be the same? We could look at another one, like the one over here. So the first one starts at 4. That's this string here. And the one that comes after, the REAS, goes until 4. So it seems like they're always the same. And there's actually a logical reason for that, because when you break something up at the kth index, so here's the substring that goes from 0 and doesn't include k, then the leftover part is the one that goes from k to the end. So they always have to be the same. But it's always hard to see the general case unless you're very good at this kind of abstract thinking. So it's always a good idea to just pick some example. And why did I pick? Why did I, when I looked for an example, why did I pick this one and not the first one? The first one is kind of degenerate, right? There seems to be something is empty, and that's not usually the one you want to pick as an example. So here, but if you go somewhere in the middle, they seem pretty regular. It doesn't matter whether you pick the third or the fourth one to get started. Pick one of them and look at what those strings actually are. All right, so now one could actually start implementing something like this. Oh, I need the class. That's word 2. is. Shifts. Oh, how do I know I'm going to use a for loop? See, you have a choice, right? You could print this with a while loop or a do loop or a for loop. Why did I automatically write for? Yes. Yeah, I know how many iterations I'm going to do. Do I? How many? It must depend on the length of the string, right? If the string is longer, then I need more than if the string is shorter. So in this particular case, I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 iterations. And how long was the string? It was also 10 long, right? Yes. So it looks like the number of iterations is the same as the length of the string. So it's a fixed number of iterations. And generally, when you want to do something a fixed number of times, the for loop is going to work out best. So I'll just write a bit of pseudocode. I'll change it in a minute. So this is text.length times. I print these two substrings. So text substring somewhere, and then the other from 0 to that same place. Oh yes, thank you. And this one is a print line. Yeah, the danger of copy and paste. So, so at this point here, I will need to have an index that runs through this, and so I'll say int I. I call it I because I always start with I with indexes, and I have two choices. I can have I start at 0, or I can have I start at 1. Yeah, so let's. The rule of thumb is that if you don't actually care about the I, if you don't use the I inside the loop, then I tend to start I at 1, because then I just goes 1, 2, 3 up to n, and that seems an easy thing to do. But if I use the I, then I want to make it as simple as possible. So let's see what those substrings actually are. So at the point over here, which substring am I taking? The first, well, let me look at this one here, because it's slightly clearer here, and then we'll move up to the first one. So over here, I take the substring starting at 1, followed by the substring from 0 to 1. That's the little r back here. So over here, I'm taking the substring that starts at 2, and then go from 0 to 2. So here I have 1, 2, 3. We went through these cases before. So it looks over here, I'll probably have to use 0. Let's double check that it's work. I take the substring starting at 0. That's good. That's the entire string. Followed by the substring that goes from 0 and not including 0. That's the empty string. So those both work. So that means I have something that wants to go 0, 1 up to presumably 9 at the very end. And then I might as well use my I as that and start I to go from 0 to 9. Okay, so then do I use a less than or less than equal here? Definitely less than. Just as a general rule of thumb, it's either 1 and less than equal, or it's 0 and less than, so at least when you iterate through a string. And then presumably, what do the i's here? And now, he said it didn't work out with netbrat. Okay, now NetBRAD, of course, complains that the left and right triangles haven't yet been implemented. So let's just put them in here as blanks. Okay, now it compiles, and NetBRAD is not happy. And of course, NetBRAD isn't happy because its expected output looks very different. It expects, the left and right triangles, which we haven't provided, and then this thing is shifted. It's not smart enough to see what's going on, and one would now have to look by hand and see that this is actually the same output. Now, if you do the left and right, NetBRAD should be okay. The only thing I'm wondering is, no, it's okay. I was wondering where this blank line comes from, but I think that blank line must come from the tester. Do we have a tester? Yeah, the tester separates them by blank lines. So in this case, it's not an expected style tester, the one that we usually have where it checks for a particular thing and then for the expected value. It simply checks whether the output that my solution generates is the same output that your solution generates. And yeah, you need to be at it until that happens. All right. Hopefully that took care of this one here. All right. The replacing thing. Let's have a quick look at that. Okay, replace each consonant group with X. So for that we need to have some strategy. What was the string? Reassuring. So replacing every consonant with an X is easy enough. We talked about that last time. But now with a consonant group, there is an issue that you have to somehow find the group. There's any number of ways of doing this, and I don't know if any is any much better than any other. So we will probably want to look at the characters one at a time. And each time we'll surely ask, is it a vowel, is it a consonant? What do we do if it's a vowel? Then we'll keep it, right? Are we building up a result string, or are we editing text? Oh, I see. We're editing the instance variable, meaning we're replacing the instance variable with something else. So when I find a vowel, I don't have to do anything. When I find a consonant, what should I do? I could replace it with X, and then what? Aha, I see. So I could check, is it followed by another consonant? And if it is, then I could say, I'm not yet going to replace it with X. But then you have to take it out, right? Because then you don't want it. So that would be one kind of pseudocode to say, for each character, I guess I called them letter, right? So for each letter, if the letter is a consonant, if it's followed by another consonant, then you remove it. Else you replace it with an X. That would be one perfectly good strategy to do this. With this strategy, you have to be a bit careful at one situation. What's the situation you want to watch out for? The very last one, right? Because at the very last one, what could happen is when you look at the next character, there is none to look at. So when you code that up, then you have to just make sure that your index is not quite the last position. But that's an implementation issue. We would say such a character is not followed by another. So, but this idea will definitely work. Here's another idea that'll work, and I think that's the one that I happened to use when I implemented it. I looked for a consonant, and then I had an index j, so at position I. So then at j equals I, and then I keep looking at the j letter until it's no longer a consonant, incrementing j as you go along. So, in other words, when let's see what gets interested over here. When I got to this point here, my I would point here. I would set a j that also points here. And then I say, well, let my j wander on until it finds the first thing that's not a consonant. What that gave me is the length of the entire group that I wanted to replace. It goes from I to j. And then I replaced that entire group with an X. Is it better? I don't know. It's a little bit complicated, right? Because you have a loop inside a loop. You have that mini loop that finds out when do the consonants end. On the other hand, it seems kind of nice and efficient because you replace the whole thing at once. So something to ponder whether you like that better. Now, there is a problem with this replacing, though, that you need to be careful of. What happens in this case here when I replace these two letters here with an X? Notice that now the string is shorter, right? And after you've done that, if you don't adjust your various indexes, they might now start pointing to the wrong position. This is always a danger when you remove stuff while you're iterating over it. So, in fact, let's just do it to demonstrate the problem. Wasn't word for it? Now it's word for it. length. So this is just straight from the lab. So now we have a constant. Um, Oh, the character at position J is not a text dot substring J, J plus 1. It's character position J. Oh, this one is wrong, right? Yes, vowel is. And now it's text equals text substring from 0 to I plus text substring from J to the end. So here is, I'll go over this in slow motion a little later. Here's the loop that I just described that skips, that keeps looking, the loop here. Here is my replacement. So I'm keeping everything up to the index I, and then everything that starts again at index J. And just for show, I'll print out what the word is right now. And that's all. Just compile it. Okay, int J. Ah. Well, that's not fair. Why did that happen?
Because J only lives as long as that forward.
That's right. So when I make the int J here, that's no good. Then its life is only the for loop. So I have to declare it up here. And now it compiles. Yeah? Oh, that would probably be, you mean in general or for this particular loop?
No, for this method.
No, my question is, I mean, I'm using a particular way of implementing this method, where we talked before that there's more than one way of doing it, and for the one where you're kind of checking whether, like, if you wanted to check that whether the predecessor was a vowel or consonant, for that a Boolean flag would seem really good, because then you would remember that decision for the next time.
Right, because I noticed that it works, but it's
Yeah.
not working very well. That method is working very well for the next one, where we try to take it off.
Yeah. So there's so many ways of doing it, but so if your strategy is I want to know what was the one before me. If you wanted to find, say, the first consonant on the strength that the first consonant, you replace that with an X, and then the other ones you don't replace, then setting a Boolean flag like that would make a lot of sense. So in fact, I could imagine a solution that uses two flags. You need two? No, just one flag. You want to know whether the predecessor was a consonant or a vowel. Yes, and that's a very good way of doing it. The loop that I was wondering about here, I have this somewhat complicated loop, whether I could make that simpler with the Boolean variable, and I think I could too. But I wanted to talk about that a little bit later anyway. All right, so let's try to test this. See, one nice thing about BlueJ is I can just do this experimentally without even having to write a tester. Oh no, that's I have to. This is the name. Okay, it's called, and this is the constructor parameter. And now I can just right-click on it and call this method. Oh, that didn't look good. What did I do wrong?
You didn't replace it.
I didn't put in any X's, huh? So. So that's reassuring, right? So you can see that each time it seems to have built this thing up. I'm surprised that it works so well, actually. So I didn't manage to demonstrate the point that I wanted to make, which is that generally you have to really worry about. Now, why the heck does that work so well? I could have sworn that when you take out two letters, and oh, I see.
You're taking the letters off or options, so if I.
Okay, I can break it. Hang on. And I'll make a somewhat synthetic word. All right, so let me show you what I did. So the word that I did was A, B, C, 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 E, D, E. That was my word. And it worked again. Okay, why does it work? So my I is here, and then J is here. Then I take out this entire thing, and I see, and then yes, and then then I does point to the next vowel because it gets incremented once. All right, now I'll make a slight change to break it. So my change is here that I say, I'll set, or actually oftentimes people will do this. They'll call this number n because sometimes one needs it elsewhere anyway. So we say let n be the number of characters, and then my loop goes from 0 to n. And now when I do the same thing, now I get a string index out of bounds exception. Why?
The length is changing.
Yeah, because the length is changing under me, and if I compute it once before I start the loop, then that's 10, but as I traverse the loop, the length gets shorter. So the remedy here would then be to recompute it. The general point I want to make is that when you shrink something that you're iterating over, it is always a possible kind of danger, and you do need to walk through this. When I say you need to walk through this, it's generally better if you do it on a piece of paper first, although probably most of you are going to do it after you've gotten the first exception to find out why that happens. So let's see here where the exception. No, that's not. I'm running out of time here. Okay, so I want to have a quick look at this loop over here. So the purpose of the yellow loop is to find the next vowel. And so I'm saying start at I with the variable j, while the substring there is not yet a vowel, increment j. Okay, why do I have this thing here? Yeah, I want to make sure that what if there's only consonants left over? In that case, I would then get to the last position, and then I would get to the position after that, and if I were to extract that substring, then I would get an exception. So this thing here is there to protect me against that. So, and this is one of those for loops where the only purpose of this for loop is to set j, and j has automatically been set by this j++, and then there's nothing else inside to do. That's why there is this lonely semicolon here. It's not a very common thing, and when you look at it, it is not an easy loop. So this is a loop that might be more clearly written as a while loop. Let me do that. So here, now the j starts at I, and I say while j is less than the length, and there's not a vowel there, while that is so, increment j. And that's probably a better way of writing that loop, if you think about it. Because now the purpose of the loop, namely to increment j, is clearly visible. It's there in the body of the loop, whereas before it was kind of hidden in the for construct. So generally, when I find that I have a loop that is like really hard to read, I do try to take a minute to rewrite it, because those loops that are really hard to read, first of all, they tend to be the ones that are most likely to be wrong. And also, when I come back to it in 4 weeks, I don't necessarily want to have to figure out that puzzle again. So it is usually worth one's while to try to do that. Particularly also for you guys, it's worth your while because it makes you think about effective ways of writing the loop. Yes, there was a question? Oh, I see. Yes, you don't have to do it when there's just one line. There are many people who say just always put them. And so you can't go wrong by always putting them. In fact, I had so many people complaining that I don't always put them that in the next edition of the book, they're all there. I'm just somehow I got used to not putting him if there's only a single one, but it really is a perfectly good idea to always put them, and it's one less decision that you have to make. Other questions? All right, let's get going with the lecture. Okay, nested loops. So this is what you're already are doing a little bit on one of the homework assignments. A nested loop is when you have a loop inside a loop. And so the typical example is here, you're supposed to be printing this triangle shape here. How do you do it? So the easiest way of doing it is to break it down into two separate problems. Problem number one is, we want to print these rows. And so how many rows we have? We have n rows. And so n times, we want to print one row. This is a row of length I, because we want to print length 1, length 2, length 3, and length 4. So how do we make a loop that prints a row of length I? Here it is. So we have a second variable j that goes up to I, and it assembles this variable r here out of the brackets. And then at the end of that process, I add the new line. So for example, so I is 1, 2, 3, 4. Pick the case where I is 3. Then in the loop over here, j goes from 1 to 3. So 3 times I execute r equals r plus the brackets. So the r starts out, I see, it doesn't say here, but r is whatever we already had. So it has these things already. Now 3 times I put in the brackets. After the third time, the loop exits, and I put in the new line that you find over here. And it's important, of course, that you first put in all the brackets and then a single new line. So when you put this loop here inside this one over here, then you get a nested loop, and it's shown right here. So here you see the outer loop, and here you see the inner loop. That's fairly common. Over here you find the same thing, where I had a for loop on the outside, and I had a while loop on the inside. Now, it's fairly common, but still people don't always like it because it can make programs harder to read. And there's always an alternative. If you don't like nested loops for whatever reason, if you find it confusing to have one loop inside another loop, the alternative is to make the inner loop into a separate helper function. So over here, you could make a separate helper function that says make triangle row, and you would have to give it a parameter. Over here, you could take this thing here and make it into a separate helper function. And I say I want j to be the position of the next vowel after I, and then I would just have to write that function here. Sometimes people make helper functions private. What is the position of next vowel and then we'll paste the code in here. I pasted the code so that I don't lose it by accident. But what I always do when I write a helper function, the first thing I always do is to write the java.doc comment for it, because right now I really know why I need this function and what it needs to be done. I will never know it as well again as I do now. So that's what I want to achieve. So I want the position of the next vowel or the length, if there isn't one. And that'll work, right? Because I go, I is where I have my consonant. I then set j to the position of the next vowel, and that's the stuff that I want to keep. And over here I have my loop, and it's almost correct. Clean it up. The only thing is I need a return j. So this is actually a very nice trick to clean up your code when you find it gets out of hand, because it makes your program now actually quite a bit easier to read. Right now, when you look at here, you can see what the intention of that inner loop was. It's self-documenting. It's right there. It also makes it easier to debug because you can debug each of the loops separately. I could, just call this method here. I guess I should make it public. And let me demonstrate that, how I might do that. So, in BlueJ, since I can always make an extra instance, so I now make one with the string XYZ ABC, and now I'll just say, hey, where's my method? Oh, I'm doing the wrong one. Yeah. So I say, give me position of the next vowel after position 1, and it says 1. Okay. So now it's buggy. XYZ ABC. Okay, I don't see it. Position of next vowel. No, wrong function. Position of next vowel. Still says 1. Why does it say 1? So my test string, let me double check that I have the right string. XYZ ABC. Oh, Y is a vowel. Oh, phooey. Yes. Let's say after 2, and then it correctly says 3. Now let's look at after 4, and then it says 6. That's the number of characters in it. All right, so I've tested this thing, and now I know that this one is correct. So this trick of extracting a nested loop into a separate method is highly recommended, and so it's a little bit funny that there's a whole section on nested loops, and now I'm telling you the best way of dealing with nested loops is not to write them, but that really is the truth. Why do I have a section on nested loops? Because if I didn't have a section on nested loops, I would get a bunch of reviewers saying, why isn't there a section on nested loops? So generally, I do prefer not to have nested loops, but sometimes they are, sometimes it's just simpler to put it in there anyway. The other reason to have nested loops is, why people like to have nested loops in the textbook, is because it gives them endless exam problems. Now, for us, that doesn't really work because you take the computer into the exam, so all you'd have to do is, paste the loop into BlueJ and you would find out what it does, but many people still take paper exams, and so it means that it forces the student to work through it. And so one way that I could make an exam problem like that is I can say, trace this loop. I could give you 2 nested loops and have you trace what the setting of the variables is inside them. And again, the rationale to do that is to check that the student understands how the loops behave. A more interesting question tends to be, so if you look at these particular examples from the textbook, here we have an outer loop that goes, that does 3 things. The inner loop does 4 things. What does the inner loop do? It prints a row of this many stars. And so we then do that 3 times, and that gives this picture. You flip the 3 and the 4, then you get 4 rows of 3 stars each. So the more interesting thing is, when I give you something, no, I don't have a question like that. But what I usually do in an exam is I'll give you a figure. I might give you this figure here and say, give me the loop for that. And then it's up to you to come up with a loop that does this. All right, but let's practice one of these questions here. What does this particular loop print? have conflicting choices. So I starts out at 1, J also starts out at 1, and so at the very first time, we print a space. I'll write a space as an S so one can see. Then I becomes 2, and 1 plus 2 is less equal than 10, so we print another space. That must go on all the way until I is 9. 1 plus 9 is less equal to 10, so we print 9 spaces. Then I becomes 10, and 1 plus 10 is 11, so we print a star. Now we print a new line. Now I becomes 2, and J is back to 1. 2 plus 1 is 3, so we print a space. That goes on for a while. We have a bunch of spaces. How many? Until this thing is 8, because 2 plus 8 is 10. That's the last one. Then I becomes 9. We print a star. And I becomes 10. We print a star. We're out of the loop. We print a new line. So the stars will in the end line up like that. And let's see if that was the majority opinion. Wow. Okay. Okay, someone who said something else. What? Why something else? So let's double check that we did it right. Whatever. Okay, well, we're not checking with it. That is a shame that you can't paste this into BlueJ. Error, not a statement. Oh, because print. Oh, yeah. Okay. And of course the semicolon. Okay, what did I do wrong? Yes, exactly. I always make that mistake. And there we go. Okay, so ponder on what those of you said something else and why something else. So again, the way to solve these kinds of problems is to do the walkthrough that I just described. And those walkthroughs get pretty tedious. You'd have to go through 100 steps. So it's a good idea to try to short circuit that. That's the way that I said, I keeps going, and to try to figure out what the pattern is. All right. Okay, here's another great question. Yes, so this one you're going to have to do a straight old boring walkthrough. So go ahead and do that while I set up the question. Okay, so I'm working my way through here. If it wasn't for something else, I'd be done. I only have one more to go. Okay, 5 is... Okay, I don't do that one. And then I is 6. And I'm done. Alright. So... Alright, so the right answer was in fact 20 if you if you watched what I was doing. If not, you can watch the movie later. And the only way to solve something like this is probably to just walk it through, or I guess type it into BlueJ.
It's almost like a bullet.
Yeah. All right. Okay, finally, let's move on to random numbers and simulations. So it often happens when one wants to write interesting programs that you want to simulate some randomness. So for example, if you want to see a bunch of bugs running around in a cage, you might want to have them start out at random positions or turn into random directions or some such thing. So, or if you want to simulate a game, you might need to generate die tosses. So there is a random number generator class called random. You make a random object with its constructor, and then you can use it as a factory for random numbers. You ask your generator, give me the next integer, and you say the next integer between 0 and some number. So let me do that right here. Oh, I have to import Java util. So every time that I call this method, I get a different number. Is that true? Well, I can get at most 10 numbers, and once in a while, I get the same number twice. But it's just like, what you expect from randomness. Sometimes when you throw the dice twice in a row, you get the same. Many times you don't. So that's this method here. What if I want to have a random number between 1 and 6? Then because this one here will give me a random number between 0 and 5, by adding 1, I get a random number between 1 and 6. You can also get random floating point numbers by calling an x double. So let's demo this really quick. And those numbers are always between 0 and 1. But they'll never be exactly 1. They're guaranteed never to be 1. So they might be 0, but so of course the chance for that is quite low, but they'll never be 1. And so here the chance of getting the same one twice in a row is infinitesimal. All right, so here's the code for what I've just kind of done in BlueJ. So when using those random numbers, the trickiest part is to turn the generator into what you actually want. So let's say for a game, I need a random letter A, B, C, or D. Some stage in the game, randomly one of those 4 letters is generated and no other letter. So which of these here is able to produce that? So let me advertise each of my choices. The first one is I want to generate a single character, and we know how to do that. It's a substring from I to I plus 1. And I is between 0 and 4. That's choice number 1. The next one here I make an integer between 0 and 3, and I add that to the value of a, which then would give me a, b, c, or d. Over here, I kind of do it the same way, except that I make the integer between 0 and 3 a different way. I take a floating point number that's between 0 and 1, multiplied by 4, so now it's between 0 and 4, but it's never 4. And then I take the integer part, which is a number between 0 and 3. Now, at this point, you surely feel that you'd like to vote for all of them. I see. So for some reason, people don't like the second and the third one. I don't like the first one. What's that?
The first one would never work because you get two random numbers.
Exactly. And they don't have to be consecutive, right? You get a random number, and, well, you said they're all knuckleheads, not me. Right? It is the popular choice, but it's not going to work. You get a random number, say 2. Now you get another random number, say 1. And then it takes the substring from 2 to 2, which is an empty string. That's not going to work. So that one definitely isn't going to work. This one here isn't going to work. Why not? What does the plus do? Yeah, it concatenates a letter and a digit. So you're going to get strings A0, A1, A2, and A3. The third one isn't going to work. Why not? Well, that one is actually more subtle. That was the one that I wanted to work, but it doesn't. And let's actually try this one out. So it does generate the character codes from 65 to 68, but it doesn't make them into a letter, really, because this thing is a character, and then I add to it an integer, and the sum of a character and an integer is an integer and not a character. And that's kind of nasty. If I want it to work, then I have to turn it back into a character like this. Oops. No, not like this. That's not going to work. I need a parentheses car. Oh. I don't want to type it all out. I'm just going to tell you. It will work if you take this entire thing and cast it back as a character. Then you'll get a character A up to a character D out of this way. So the true answer is none of the above. The way I would really do it, if I had to do it, is I would say n equals this thing over here, and then I would say a, b, c, d dot substring from n to n plus 1. And this way I only call the generator ones. That would probably be the easiest way of doing it. All right, so what's the use? You can use the computer to simulate things that are boring to do by hand. So for example, this French mathematician Buffon has, 200 years ago, designed this experiment that said, if you, on a sheet of paper, you draw horizontal lines, and now you make a needle, and the distance between the lines is exactly twice the length of some needle, like a sewing needle. And then you keep dropping the needle onto the sheet of paper. And you compute how many hits you have and the ratio of hits to tries is, I think, pi over 4. Or is it pi? No, so the ratio of total tries over the actual hits is actually the number pi. So if you throw it 100 times, and the hits, and you might get like 27 hits, and if you divide those, then that ratio is approximately pi, if you keep doing it for a long time. So if you do it for 100 times, it might not be very close, but if you do it 20,000 times, which he apparently has done without a computer, then you get pi. So run that program at home. I'm running out of time here. I was going to do it. Well, maybe I can do it really quickly. I'm just doing it under the command line because it's faster than using BlueJ. So here it ran it, first of all, 10,000 times, and it got some approximation for pi, and then it did it 1,000,000 times, and it's gotten a little better. And when you run it multiple times, the estimate that you get is a little different every time, which is what you would expect from a program that uses randomness. I can only tell you that Monsieur Buffon would have killed for this program. All right, so that's it. We'll regroup on Monday and get into arrays.